So welcome to this special edition of Data in Azure. I'm really glad to have you here today. And what I'd like to do is talk about some of the more important aspects of differentiating the different opportunities to store your data in Azure. Now, it may not sound that interesting, but it's actually crucial because if you don't have your data, then you don't have your business. And many technologies, such as artificial intelligence or data science, absolutely must have the data in place and in the right format. So my name is Jennifer Stirrup. I'm a Microsoft Most Valuable Professional and I'm a Microsoft Regional Director as well. I also work for myself and I spend my life doing business intelligence and artificial intelligence solutions for organizations in the enterprise. So I'm excited to talk to you today about data in Azure. What I do see is organizations tending to treat Azure like it's some giant USB stick in the sky that's going to store all of their data for them. And while it can do that, it can actually do so much more. But in order to make good access of things like artificial intelligence or data science, you really must have your data in the right format and in a good place. So let's see what Azure can actually give us in order to help you to get to a good place with your data. So here's our agenda. We're going to focus specifically on big data technologies such as Azure Insight, Apache Spark, and Databreaks. We will also talk about some of the other technologies as we go, but that's our focus for today. So what we have initially is Azure Insight. This allows us to do big data processing. We can tear Insight up and then tear it back down again when we don't need it. It allows us to do a range of processing on Hadoop technology. It's actually an implementation of Microsoft and what was Hortonworks technology in Azure. As we know now, Hortonworks have been bought over by Cloudera, so we now have access to that technology in Azure. So what does HD Insight actually give us? Well, it gives us opportunities to deal with batch processing and real-time processing as well. For example, we can use HBase, which is a NoSQL workload. It's a distributed database which offers random access to large amounts of data. We can also use Apache Storm as well, and that's for streaming data workloads. That's for the hot data that's coming at you very fast. So that allows us to do real-time analysis of moving data streams. We can also use Apache Spark as well. So that's for high-performance, complex workloads, where you tend to set it and forget it until it's processed all of the data and then comes back to you. It's very fast, and we're going to talk more about that during this session. So Azure HD Insight obviously runs in Azure, and it operates a number of open source frameworks, including Apache Hadoop, Apache Spark, and Apache Kafka. Now, if you have a LinkedIn account, you probably use Apache Kafka without realizing it. LinkedIn uses Kafka as a way of processing data in real time and in very large amounts. We can imagine how many people are using LinkedIn at any one time. So Azure HD Insight itself is a very cost-effective way for enterprises to move forward with open source analytics. It gives you the opportunities available to you with open source technologies. And it also allows you the robustness of a proprietary supporting network, such as Microsoft Azure. It does mean that you can use Azure to process large amounts of data. So you can store it in Azure like a USB stick, but you can also process it as well using open source analytics. It really means you can spin up big clusters as and when you need them. You can scale up or scale down in terms of the size, and you pay only for what you use. It's a great way to get started with open source technology with the secure knowledge that you're using a well-established framework of Microsoft Azure. So one question I often hear is about the security of the data when we use cloud technologies. HD Insight allows you to meet industry and government compliance standards, which are part of Microsoft Azure. It allows you to protect your enterprise data assets using Azure Active Directory and an Azure Virtual Network. HD Insight can also connect very well with other Azure technologies, such as Azure Data Factory, which is extremely useful for pushing large amounts of data around in the cloud. You can also use data lake storage as well, which is optimized for high-performance analytics. So Microsoft Azure HD Insight allows you to stay up to date with the most up-to-date open source frameworks, including Apache, Hadoop, and Spark. And like we mentioned, you can use other technologies such as Kafka, HBase, and Hive. It has native integration with other data sources such as Azure SQL Data Warehouse, Azure Cosmos, Data Lake Storage, and even blob storage as well. When you're using big data technologies, it's often a concern how well those are performing in terms of performance and robustness. Fortunately, Microsoft Azure provides simplified monitoring. You can use Azure HD Insight with Azure Log Analytics, and that allows you to monitor the performance of all of your clusters. It also allows you to use multiple languages and tools. You can use Visual Studio, which is a home for many developers. You can use Eclipse, IntelliJ, and Jupyter and Zeppelin. In the data science world, Jupyter is very, very common. You can also use intelligent and familiar languages such as Python, R, Scala, JavaScript, and .NET. So for programmers who already use these technologies, it's not much of a jump to using those to adopting new technology in Azure HD Insight. So with that Azure HD Insight in mind, what other opportunities are there to use technologies in Microsoft Azure to store our data? We can use Azure for many open source technologies, and we can also use Apache Spark. So Apache Spark is part of Databreaks, but it's important to understand what Apache Spark is before we start. Apache Spark is an open source software solution. It allows you to work on data that's held in memory. Apache Spark is what's known as resilient, and that really means that models can be created and recreated on the fly from a known state. The data is also distributed. And what that means is that the dataset is partitioned across multiple nodes, and we can use that for increased scalability and parallelism. The basis for Apache Spark is what's known as RDD, Resilient Distributed Data, creating models on the fly and partitioning the data across multiple nodes. And that's what makes it so popular. It's also popular because we can use it with Python, R, and Scala. We can also use it with Jupyter notebooks as well. Apache Spark also has native integration with Hive, HDFS, and any other Hadoop file system. Scala has about 3 times less code than Java, so it can be easier to read. It can also be faster for iterative jobs, and it also promotes code reuse as well. So basically, to summarize, Apache Spark offers a unified platform for your data, for storing and for processing it using multiple workloads. That includes very hot data sources such as real-time processing. Spark also allows you to do machine learning, streaming analytics, interactive querying, and also data visualization as well. So Apache Spark also offers you in-memory processing for really big data. So it allows you to create those models on the fly and use data in order to, as a basis for your processing where you have really big data sources. It also has APIs for processing large datasets, and it's up to 100 times faster than Hadoop. So with that in mind, when we have Apache Spark, why would we need Databricks? Well, Azure Databricks is an end-to-end managed Apache Spark platform which exists in Azure. So we have the opportunities of using open source technologies, but we also have the ability to use the robustness of Microsoft Azure as a platform for doing big data analytics in the cloud. Databricks is also optimized very well for Apache Spark. It can improve Apache Spark jobs by somewhere between 10 to 100 times. So if you consider that Apache Spark is already increasing the speed of Hadoop by 10 times, Databricks is taking that speed and applying optimization to it, so it's even faster again, between 10 and 100 times faster than Hadoop and Spark. It's also cost efficient to execute large-scale Spark workloads. Often when organizations are getting started with big data, they have a decision to make whether to purchase a large amount of hardware or whether to get started in the cloud. And they can do that so they have a low friction way of getting started with their data science opportunities. So here's a slide which explains Azure Databricks in more details. To make sure, I'd like to credit Microsoft for this diagram. I've put the credit in there if you'd like to go and have another look at it. So with Azure Databricks, we can do many different things. We can do data science, we can do data engineering. Data engineering is about making sure that the data is in a good, clean state. If you don't have that, then the data science will be ropey, and so will any artificial intelligence and business intelligence based on it. Azure Databricks offers you a number of things to help you to get to speed very quickly. It offers the notebook experience, which we're very familiar with Jupyter. So straight away, data scientists are able to pick this up. We can also use Databricks workspaces, which means you can tear them down and start them up again as you like. And they're also a very good way of managing things separately, perhaps by project. We can also use Azure Databricks Enterprise Security for when you are using data which is particularly sensitive. So you have the opportunity to implement security policies and secrets on that data. So with Azure Databricks, it also connects to a number of different data sources. We can use it for blob storage, which is a bit like a data attic, a place where you can store your data and just put it in the cloud. We also have the Azure Data Lake Store, which is an optimized way of storing data, especially for analytics and for high performance. We have the Azure SQL Data Warehouse. So if you are a retail outlet, for example, it's very often good to have a data warehouse in the cloud so you can examine transactions as they are in flight. Apache Kafka, we've already mentioned, that's for very high-speed real-time processing. We use it in LinkedIn. And we've also got Hadoop storage as well, which is cheaper, can also be slower as well. And Azure Databricks can be used with many applications for deep learning, for example, which is basically a way of taking neural net models and stringing them together so you can do more complex things. We also have data warehousing. You can use Databricks as a way of analyzing and sorting your data for your data warehouse. And you can see the data in Power BI. And that's Microsoft's premier technology for visualizing data. So to summarize, Azure Databricks is a one-click deployment, has auto-scaling features, and offers an optimized Databricks runtime. That can improve the performance of Spark jobs in the cloud by 10 to 100 times, and it makes it very cost-effective to run very large-scale Spark workloads. So Databricks is excellent for data engineers who need to make sure the data is clean and in good quality. Databricks offers you an interactive notebook environment, and it allows you to use monitoring tools and security controls. So you can use Spark in enterprises that have got thousands of users. Databricks for big data. Data scientists are familiar with the interactive notebook environment, and it means that you can use Databricks for really doing some great analytics on your data. One place it's being used at the moment is you can see it's been used in Shell. Shell are using it for analysing forecourt traffic, and they can use it for things like analysing if someone's dropped a cigarette or something like that. So it's been used for real safety purposes. If you want to see that case study, you can look at the Microsoft YouTube channel. Data science is a great opportunity to understand data, but we have to make sure that the business users understand it as well. So Databricks offers us the opportunity to visualize our data using Power BI. It's also supported by Azure SQL database. So what that means is you could put your results into an Azure SQL database, and Microsoft Power BI could pick the data up from there. Notebooks also allow great collaboration between data scientists, and that's one great reason that Azure Databricks is so popular. So here we have an example of different data stores. We have Azure Databricks and we have Data Lake Analytics. So both Azure Databricks and Data Lake Analytics can be used for batch processing. So how do we know which one to choose? Well, Azure Data Lake Analytics is a distributed computing resource. It's excellent when there are large amounts of data where conversion and loading are only actions needed. It uses Microsoft's proprietary USQL language to allow you to really crunch through that data and to load that data into Azure systems and also non-Azure databases as well. It allows you to work with distributed processing and distributed data in a SQL-like language. So that means it's easier for data engineers to get started with it. It really is excellent for repetitive workloads with no intermediary actions required. So just to summarize, Azure Databricks is a notebook type resource. It allows you to work with high performance clusters, and that allows you to really crunch through that data to perform computing, and it uses in-memory architecture to do that. So Databricks is better for processes that require intermediary analysis of data. It's also good for ETL that requires more visibility during data transformation and modeling. Databricks also has a number of APIs, which allows the connection to various data sources, such as SQL, NoSQL, and file systems. So it has a wider opportunity of connectivity to different data sources. So Data Lake Analytics is really a cloud-based file system, which is virtually unlimited in its size. Azure Insight can also do a similar job in the cluster that you make, but when you stop that cluster, the data also goes away. So that's one differentiator between HD Insight and Data Lake Analytics. With the Data Lake, that job service runs and the data remains. But with HD Insight, it's primarily used for processing data, so when you tear down the managed cluster, it goes off as well. HD Insight is an analytics service, whereas Azure Data Lake Storage is a storage service in itself. You most likely need to have both in a functional analytics cluster. HD Insight gives you the cluster, manages the open source packages for analytics, such as Hadoop, Spark, and so on. And you can set up your cluster to use Azure Data Lake Storage. That gives you HDFS API, which allows you to connect to the Hadoop file system, and you can do that on top of cloud storage. So it's important to add technologies such as Data Lake Analytics and HD Insight. You can actually use both of those. Data Lake Analytics to preserve the data, and HD Insight to really crunch and process through that data when you need to do that. Slide number 23. So I've put together a bit of a diagram to try and explain when you can use different data sources in the cloud. So looking at it from the database angle, we could have SQL Server on a virtual machine, or we could use Azure SQL Database. Now, the thing with Azure SQL Database is that you could see that as database as a service, and Microsoft look after that for you. On the other hand, if you use Microsoft SQL Server on a virtual machine, you're responsible for the maintenance and the security on that. So Azure SQL Database is now accessible via HTTP REST, as is Azure Cosmos DB, which is a very large operational data store, which can connect to other APIs such as SQL, and it can use Gremlin as well. HBase is the Hadoop file store, which is accessible through REST as well, and we can use Azure Blob and table storage. I don't tend to see table storage that much. I do tend to see it for financial data, where you can use table storage in order to take down Sentinel data from some of the guardians of the finance world who produce currency data, for example. You could then crunch through that file and store it in a table. It tends to be transient if it's a currency transaction rate, for example, so it may not be something you need to store for very long because it gets updated anyway. So with Azure SQL Server, you manage that yourself. Azure SQL Database, you get that managed for you. So things like Azure Databricks and HD Insight, those are cloud-based big data services, and you can quite easily spin up that service, but some of that, the engineering and the plumbing around looking after that, is done for you by Microsoft Azure. You can also scale as well and keep adding in more and more data. When you do that with an Azure SQL Server on a virtual machine, if you want to scale, you have to think about how you scale that out. So also with the Azure SQL Server on an Azure virtual machine, you need to use a schema-free model as well for other technologies such as Azure SQL, Azure Cosmos, and HBase. But for the SQL Server on a virtual machine, you need a schema to do that. All of these technologies are available for transactional processing. I should point out that SQL Server and Azure SQL Database are fully featured relational databases, and the others are big data sources, so not so much an emphasis on relational there. You can also do rich querying in these technologies. Apart from Azure Blob Storage, what you would need to do is put a lens on that data, then query it after that. Azure Databricks and HD Insight are both great technologies, and sometimes it's hard to work out which one you should use. So Databricks is more focused on collaboration. Streaming in batch is more focused on a notebook experience for the user. Databricks integrates well with Azure, has good Azure Active Directory authentication, and it can export to SQL Data Warehouse, Cosmos, Power BI. Its greatest strength really is its zero management cloud experience, and it gives you that collaborative, interactive environment, which gives you a great form for notebooks. On the other hand, HD Insight has got Apache Kafka, Storm and Hive, which Databricks does not have. HD Insight can be good for processing very large data sets if you just want to set it and forget it. Sometimes you can see both of these technologies used. Databricks can be more friendly for data scientists, and it can be better for exploration where you're not that familiar with the data source, whereas HD Insight is better for processing data. So here we have another diagram to try and explain more clearly how we have the difference between user control and ease of use. So when we look at the Azure Marketplace, you could use Mapr or Cloudera. That would involve a lot of user input in order to set that up. As we move towards HD Insight, Databricks and Azure Data Lake Analytics, they become even easier to use and set up. Azure Marketplace can involve using infrastructure as a service, but then as we move towards Databricks and Azure Data Lake Analytics, we're looking at big data as a service there. With Azure HD Insight, you have to do more work in order to manage those clusters. You can also connect these data sources up to Azure Data Lake Storage and Azure Blob Storage. Azure Blob Storage is cheaper, but Azure Data Lake Storage is more expensive, but it's more optimized, and it will be faster for those big data loads. Azure Databricks is faster than Apache Spark, as we said. HD Insight is very effective on large amounts of data, You can easily spin it up and tear it back down again. You don't obviously have to install any hardware for either of those, but some experience suggests the processes can be slightly slower in HD Insight than with Databricks. Databricks, as we know, is very optimized for speed. What about the learning curve? Well, Databricks is a good technology regardless for the experience that they have already. Databricks has a real emphasis on speed and trying to make big data easy, so every organization can use it. It really is trying to simplify those systems to make things easier for people to work with. Azure Databricks is Spark-based, which means you can use Python, R, and SQL along with it as well. This saves users from having to learn another programming language for the sole purpose of distributed analytics. So just to summarize, Azure Databricks and HD Insight offer different language experiences. So HD Insight offers Java, Python, .NET, and Go. And HD Insight clusters include Spark, HBase, Kafka, and Hadoop. HD Insight also supports languages that are supported in Hadoop, such as Pig, HiveQL, and SparkQL. You should note, however, if they're not installed by default, you need a script action in order to install those. With Azure Databricks, we have Python, SQL, and R, and Scala. So these are very commonly used languages anyway. So just a quick note about the pricing. Azure Databricks offers a purchase plan as well, and you can get up to 37% saving over pay-as-you-go. On the left-hand side, we can see the Azure Databricks pricing here. It bills you for the virtual machines that are provisioned in clusters, and these are measured in Databricks units, DBUs, based on the VM instance selected. A DBU, or Databricks unit, is a unit of processing capability. It's billed on a per-second usage basis, and the consumption depends on the size and type of the instance running Azure Databricks. On the other hand, HD Insight is billed by the minute. Clusters run a group of nodes depending on the components that you've clicked and selected. HD Insight doesn't offer a pre-purchase plan, so it really comes down to, in some ways, how your accountancy is going to work out. So we have data objects in Azure Machine Learning. Now, the whole point of understanding what data goes where is good to understand those data sources, so that can help you to step forward into using Azure Machine Learning to get started with using artificial intelligence as well. So you can access data in different ways using Azure Machine Learning. You can access that using a data source and a data set which you set up in Azure Machine Learning. It means you can consume data in Azure Machine Learning runs. And to do that, you set up the Azure Machine Learning Designer, or you can interact with it using the Azure Machine Learning SDK for Python. It also does a really neat thing called data drift. So you can set up dataset monitors in Microsoft Azure Machine Learning, and what that allows you to do is work out how far your data is changing over time. So when you deploy a model, at that point you're thinking that the model is in good shape to match the patterns and the characteristics of the data. But over time, that data can change, and you want to see and measure how that data has changed over time. So to create a data store in Azure Machine Learning, you, as a data scientist, can reuse data with one reference. That's really handy if you have very big data files, for example, and it's not a trivial exercise in order to move and copy those around. So if the data source is very large, then it's useful to reuse the connection to one source, rather than having numerous copies of the data everywhere. The same data can be shared with different data science teams across different projects. And the dataset reference itself is carried through model training, which makes the model a bit more simple to work with. In Azure Machine Learning, we have two main types of datasets. We have a tabular dataset, where the data is materialized into pandas or a Spark data frame, or you have file datasets, where multiple files can be referenced in the data store. Those are referenced through URLs, and you can download them and upload them. You can create both of these using the Python SDK and also in the portal as well. You can also use the Python SDK, and here's some code that allows you to see how readable it is. All we need to do is set up the workspace details for Azure Machine Learning, set up the data store, and set up a data set. Then we can print out those details so that we can see them properly. To summarize, in this session, we have looked at some of the main data stores and data sources that are available using Azure. So we have looked at Apache Spark, we've looked at Databricks, we've also looked at Azure Insight. There are plenty of other Azure data sources to choose from, but hopefully that gives you an overview. And basically those form a great basis for using with technologies such as Azure Machine Learning in order to get you started on your analytics journey. So my name is Jen Stirrup, and it's been my pleasure to be with you today.